In this video, we're going to be looking at compound interest. Looking at compound interest, we have two equations we'll be looking at that will help us to solve compound interest. The first equation, we say A is equals to P open bracket 1 plus R all over N cover bracket NT. Right? Now, to define the terms within this particular equation, A is a future amount. The amount you are going to get after you've credited an account for interest over a period of time. P is a principal amount, which is the present amount, the amount you deposit in a savings account or something like that. R is the annual rate. N is the number of times you receive the interest rate in a given year. So if, for instance, a question says monthly, you know that N is equals to 12. If a question says weekly, you know N is equals to 52. If a question says quarterly, N is equals to 4. If a question says annually, N is equals to 1. If a question says semi-annually, N is equals to 2. And T is basically the time in years. So let's look at an example. Looking at this particular example, the question says, James put 20,000 in a savings account, paying 8% annual interest, compounded monthly. At this rate, how much? There's supposed to be much here. Sorry. My pen is overflowing. How much money will be in the account after 40 years? So we want to know how much will be in the account after 40 years. So let's look at the parameters in this equation. First of all, we know the principal amount, which is the amount put in the savings account, P. Solution first. P is equals to 20,000. Right? We know that the rate R is equals to what? 8%. And then you can do that by saying 8 divided by 100 because it's in percent. So what you get is 0.08. Right? So we know that the N, which is the number of times we have been credited with the interest, N is compounded monthly. So therefore N is equals to what? 12, because we have only 12 months within a year, 12 months within a year. The time T is what? 40 years. So now put all of this in the equation above. A, which is a future amount, and that is what we are looking for, is equals to P, which is what? The principal is 20,000. 20,000, open bracket, we have 1 plus R, which is what? The rate is 0.08 divided by N, which is a what? The number of time you are credited within a year, and it's monthly, so it's 12. Raised to power raised to power 12 is 12. N is 12. Multiplied by what? 40. So now, next we say 20,000 multiplied by 0.008 divided by 12 plus 1. What you have is going to be what? 1.006667. So 12 times 40, you have 480. Right? Next, we say 20 multiplied by 1.008 raised to power 480. What we have is 485,467.79. So that's the amount that will be in the account after 40 years. Let's take another question. So the question says, Rose invested 100,000 in an account paying 7.2% interest, compounded continuously. How much money will be in her account after 30 years? Now, the first equation we treated from the question 1, there, if you look at it closely, you see that it said compounded monthly. So when you see compounded continuously instead of monthly, weekly, yearly, or something else, once you see continuously, compounded continuously, you use the second equation, which is what? A is equals to P exponential RT. And in this equation, A and P remain the same, just like in the first equation. So we have A, which is the future amount, P, which is the principal amount. Now R is the annual exchange rate as a decimal, and then T is a time in years. E is basically the inverse of natural log function. So from our question above, we know that the principal amount, which is the amount invested, is what? P is equals to what? 100,000. So we know that the rate R is equals to 7.2%, which is going to be what? 7.2 divided by 100. You have 0.072. Then we have our time, which is what? 30 years. So we input all of this in the equation above. We say A, which is our future amount, is equals to P, 100,000, exponential. Then we know R to be what? 0.072. We know that T, the time, is equals to what? 30. Next, we say A is equals to 100,000 exponential 0.072 multiplied by 30. What you have is 2.16. So A, which is a future amount, is equals to, when you multiply 100,000 by exponential of 2.16, what you have is 867,103.77 cents. So that is the amount that Rose will have after 30 years if the interest is compounded continually. So that will be all for this video. Thank you so much for watching. Please do like, subscribe, share, and if you have comment or question, please write it at the comment section below. Thank you for watching.